Okay, let me get roll done here really quick. You're missing some people today, huh? So far?
I never mind. Sorry.
What was that?
Oh, nothing. Never mind. 183.59.
Okay, we'll give it just another minute or so. Alrighty.
Hey, Garrett, what's everyone working on? I'm sorry, I just jumped.
So right now we're just waiting for one or two more people to see if anybody else is going to show up. We'll probably just get started though. I know a couple people are going to be late, or I was expecting to be absent, so. As far as the quiz for yesterday goes, I will be getting that graded. I haven't had a chance to yet, so I will make sure that gets done and that it gets posted as soon as possible. And again, I'll put that just in your individual folders. So. All right, let's get started here. So, today we're going to be talking about those charts that we've kind of been looking at the last couple days. We're going to introduce you to the program we use for our flight planning, which is SkyVector. Now, something that I'm going to tell you guys right now is SkyVector is a great program, and it's going to help us in our flight plans. It kind of takes a lot of time out of our flight planning that we'd normally spend flipping through charts and stuff like that. But on your practical test, you're going to have to use the actual maps. Now, don't worry, they're identical. SkyVector uses the same exact information. It's just in paper form. So we'll go over that. We're going to get really in depth with that and make sure you guys are comfortable looking at these charts. But yeah, so do you guys remember the types of charts that we've talked about so far?
I have like. Are you looking for something more specific than IFR charts?
Yeah. So
Um,
the actual chart names that we've been looking at.
like, wouldn't one be called a high en route? It's like a like highway charts,
So high in
sectional
route's
charts.
good. Yep, high in route, sectional, terminal when we're talking about larger, more busy airports. Low in route, right? And these charts are both IFR and VFR charts. So I'm going to need you guys to really pay attention to. So we're gonna do some videos here. I really want you guys to pay attention during this video. Take really good notes. And let me pause that really quick. So it's just going to go through all the basics of these charts, okay? How to read them, what you're looking at. A lot of it we've kind of covered. So sectional charts, we're not really going to be using sectional charts a whole lot in this class, but you still need to be able to read them because they still pertain to you, and you need to know the information on them. And then, yeah, so we're going to go through sectional charts first, and I'm going to paste this this YouTube video in your chat here. So that video is 12 minutes long, and then we'll get back on. We'll talk about it and go over some of the questions that you guys have. Take notes through the video, and you know, mostly what I want you guys to remember are the types of routes that you're going to see. You know, information about what you're looking at an airport. Navigational aids, pay attention to those and how to read the information boxes on the charts. Tell you the frequency, you know, and different things that pertain to those navigational aids or airports. So pay close attention to that. Take notes. We'll get back on, and I'll just kind of go through it again with you guys and make sure we got all the necessary parts. So everybody mute your mics again, and let's start there. All right, guys. Sorry about that. Okay. So, what were some of the key takeaways that you guys got from that? Does anybody have any questions about it? I saw, CJ, you put that there's a lot of notes that you were taking.
I wrote down every single tiny little like icon like this. My page looks like the legend on the side of a map right now. I don't know if that's what I was supposed to do or not, but
No, that's great. Anything you can do to help you remember this, and remember this is going to be in your Google Drive, and you'll be able to come back on it and look at these videos and these links as many times as you need to. I have to refresh myself on these charts as well every once in a while because there's just so much information on them. So yeah, I mean it's not the easiest thing to understand, but at the same time, it's good to have YouTube and those things to help us. You get a lot of information.
Mm-hmm.
So, anyways, you guys can see me kind of scrolling through this map. We'll zoom in on some of these areas. So, some of the things that are really important to take away from this. So, remember that these are visual charts. These are for VFR, right? But at the same time, when we're coming into an airport, the pilots at some point in time are probably going to be looking outside their cockpit just to kind of, even for their own reference, to look outside. So these charts still do play a role in what we do, just not as big of a role since we're flying IFR and their instruments are guiding them. When we talk about these airports, the star up here is a rotating beacon. You've got the airport here. If you have these tick marks on the side, right? Does anybody remember what those dashed rings are? Or I mean the
Plus sign.
crosshairs are?
Yeah, it basically means it has services of maintenance, fuel, etc.
Right. Okay. Some of these stars here just means that it has a rotating beacon at the airport. So a visual identifier that's an airport. You probably see these driving by airports all the time. You just maybe not have known what they are if you see that white and green flash next to an airport.
So one question. So yeah, like I said on the video, the RP13. So I got it. It basically means a left or a right down or a right or down pattern.
These L's and R's.
And when it says like the number next to it, they're displaying that in hundreds, right? Like so, 13 would be 1,300 feet.
Where this number right here? Can you see my mouse? This number right here.
I can see it, but it's too small.
So you're.
I think it says 1390.
1395. So
1395.
Right. So that would be your field elevation. So.
Well, I meant for like your traffic pattern.
So for your traffic pattern, again, your traffic patterns are going to be for VFR use. So VFR, the field elevation is 1395. Typically, your traffic pattern is 1,000 feet above the field. And a left downwind just means that the runway will be on your left side when you're flying your downwind pattern. So once again, that's not something that we're really going to use because we don't use those patterns, those VFR patterns in our 121 flights. And if we do, it's probably not a flight you're going to be concerned with because it'll be a supplemental operation, right? They're out testing the landing gear that got stuck down or something of that nature. But that L, would mean a left-hand pattern. The 50 next to it, I'm as zoomed in as I can be, I think. Can everybody see that? So that 50, that's the length of your longest runway. That's kind of important to us as dispatchers because we need to know our runway lengths, and we'll look at where we can find those. We use what's called the AFD, Airport Facility Directory, right? That's where we're going to get our information for runway lengths, and we'll also look at the approach charts. Will also have our runway information on them. So, yeah, just some really good information on these for visual flight, especially. Like it said in the video, you've got, it shows you the major highways. It'll also show you like these Victor Airways. We actually can use these Victor Airways. Does anybody remember what the altitude that our Victor Airways go up to?
45,000 feet.
So the Victor Airways
No.
are Class E airspace, right?
14 to 18,000 feet.
Yep, typically. So yeah, our Victor Airways, we'll use those for navigation. It shows us our lakes and things of that nature. There's also these big numbers that you can see. And what that is telling us is the highest point in that area on the map, right? So in these sections of the map, that's telling you the highest obstacle in those areas. Okay. So does everybody see these big numbers right here?
Yeah.
So that's important, right? Looking at approaches and stuff like that. Oh, that's kind of a fun. So what are these called again? Oops. Let me zoom in again. What are these called? These red areas on the map.
Those are TFRs.
Okay, yeah. And this TFR is for aerial demonstrations, and it's in El Centro. So what do you think's going on there?
An aircraft show or an air show.
Okay. El Centro, does anybody know what El Centro's known for?
No.
So that's the winter training grounds for the Blue Angels.
Oh, that's cool.
Yeah, so the Blue Angels are practicing sometime in that window. Used to see those a lot over Pensacola when I lived there, because Blue Angels during the summer practice in Pensacola. So kind of fun. But anyways, yeah. One other thing that's kind of important to take away from these maps that we also use is, again, dealing with obstructions or obstacles would be your. Does everybody see this tower indication on the chart?
Yeah.
Yes.
So what did the bottom number? What does that indicate?
That means 2633. Doesn't it mean that's the length of the tower?
Okay, the height of the tower.
Not the base. So the base, and then on top is the height.
So the 360 is above ground level. So that means that these towers are 360 feet tall. Okay.
Okay, and at that altitude, it happens to be 2,600.
So the 2633 that you see there, I hope you guys can see it. Oh man, what just happened? Okay, so this 2633 on top that's not in the parentheses, that means, or that is giving you the MSL. So when we're flying, our altimeter is going to be reporting to us the MSL, right? We're going to see 2,633 feet, and we're going to be scraping the bottom of our aircraft on that tower. So
the bottom number is the ground level, and the top number is the tower height.
nope. So
Sorry.
no, you're fine. So each one is indicating the height of the tower. Okay. So the top number is what the top of the tower is, mean sea level. Okay, so that means the height above sea level, above the ocean, right? And the bottom number is
AGL.
AGL, which is above ground level. So that's just saying that that bottom number tells you that the tower is 360 feet tall.
Okay.
And what the top number is telling you is that the top of the tower, what you'd see on your instrumentation in your aircraft, is 2,633 feet above sea level.
Hey, Garrett, on these maps, is there always a legend on the side or something?
Yeah, so if you have the actual sectional charts, you
Is there one on the one that you have right there? Can you just show us that?
So not on SkyVector. I have not found the legend for it. But if you just do a Google search for sectional chart legends.
So I wanted to see if I don't know if this is important or not. So when it says like the restricted airspaces, when it has that R, and it has like a number next to all the R's. Is that important, or is that just military for military people to view?
So are you talking about these R's?
Yeah, like the restricted airspaces, and then it has a number next to them.
Oh, so you're talking about these on the map, these blue hashed areas?
Yeah, you
With
see
the
how it says like,
restricted R2524 there?
yeah. Do we have to pay attention to that?
Yeah, so that's just saying, yeah, so to enter a restricted airspace, we have to have clearance from the authority over that restricted airspace. So our restricted airspace, it's giving you a number here so that you can find out who owns that airspace and get
Okay.
that permission.
Okay.
So we could look up R2524 airspace, and this is going to give us who owns it, basically, this complex user handbook. It's in the AFD, so you can find out exactly who owns that airspace. And it'll actually give you a telephone number where you can actually call that whoever owns that restricted airspace and get that permission. Okay. or request, say I'm going to be flying through next Saturday. Would I have permission to enter that airspace? And they can tell you what's going on and things like that. So
Okay.
But yeah, just if you want to see a legend for all of this, it's going to if you just do a Google search, for some reason SkyVector, I don't know why the key isn't on there, but I haven't been able to find it. What's kind of cool about SkyVector as well is that we can look at charts. So if you want to look at the actual like Salt Lake City chart, you just click on that area of the map and it'll give us a Salt Lake chart. Oh, actually, there you go. Just found it. So does everybody have internet access right now?
Yes.
Okay, so
Yeah.
We'll kind of dive into the introduction into SkyVector a little ahead of schedule here, just so you guys, maybe as you're watching the YouTube video, you can kind of follow along with them as well. Okay. Type in skyvector.com and it'll pull you into a map kind of like this. Okay. Is everybody there? So
Yeah, you want us to zoom into Salt Lake?
Nope. So I want you to click up near the top. There's a button that says charts and it has a globe. Just click on that. And then click on the Salt Lake area. And if you zoom out and scroll to the left, you'll see the legend, the key on there. And it'll give you information about the airspace. Also on the sectional charts is where you can also find those restricted airspaces. And like I said, it'll give you frequencies, or if it's not if there's not somebody monitoring a frequency, it will sometimes also give you the telephone number to contact the presiding authority. It'll give you also in that left side, it gives you the hours of the different control towers on the map.
Okay, so I'm on it, but I'm not seeing the legend pop up. So
did you click on the charts? So click on that globe that says charts. And then
You know where it is on
top left.
global? I was using my phone.
Oh, okay. On what?
I'm just on my phone.
So if it takes you to an IFR chart, if it doesn't look like the map we're looking at here, click on the button that says World VFR.
Yeah.
Okay.
And there,
that's what I'm on right now.
okay. I think I'm in the right spot.
Now click on
Maybe I'm just so zoomed out I can't see anything. Okay.
Click on the button that says charts in the top left corner, and then click on the one in the Salt Lake area. It'll take you to into the chart.
Oh.
Now scroll all the way to the left side of that, and you'll see the legend on there. Okay.
Okay, I see it.
So you can look at this, and it'll show you. It'll help you identify all the classes of airspace. Okay. It'll also give you these VOR, the communication boxes. This is kind of important, right? It'll give you kind of a breakdown of what's in those boxes, the information in those. Some of the different like special miscellaneous symbols that you see on the map. It gives you a definition of what those are. You can see this color gradient too, that will tell you the height or the altitude of those different areas. So those big numbers that I was telling you about earlier, there's a box there that says this chart contains maximum elevation figures. The maximum elevation figures shown in quadrangles bounded by ticked lines of latitude and longitude. So each one of these boxes of longitude and latitude will have one of these numbers in it, one of these big bold numbers. And what that says is it says it's represented in thousands and hundreds of feet above mean sea level. The maximum elevation figures are based on information available concerning the highest known feature in each one of the quadrangles, including terrain, obstructions, etc. So that's what I was just telling you before, was those big bold numbers are your highest obstacle in that box. So yeah, it tells you the different airports, what to look for. It'll give you topographical information. And then, like I was saying before, it gives you the control tower frequencies and the hours of operation. It'll give you the approach control frequencies. So those are important when we're doing our approaches, right? Yeah. So if you guys ever have any questions about what one of these figures or anything means, then it's a good place to go. One thing to kind of look at and note that's going to be on every one of these maps is these ticked lines of longitude and latitude. Do you guys remember? So which line is longitude and which line is latitude?
Longitude would be the lines going up, and longitude would be going across.
Okay, yeah. So latitude is vertical, longitude is horizontal, right?
Mm-hmm.
Each one of these tick marks on the map, on those lines, represents minutes. Minutes of angle, or minutes of longitude or latitude. And then you'll also see these magenta ticked lines that run kind of at a diagonal path through the map. If you follow those magenta lines, you'll see, and this is going to, once again, this will be on every one of the charts. You'll see a number on that ticked magenta line. And what that is your magnetic variation. You guys remember what that is?
Yeah, it's different numbers depending on what part of the country you are, because the magnetic heading is going in a different direction every time you move across the United States. So it's going towards the top, right?
So yeah. So our compass gets its course based off of magnetic north, right? Well, magnetic north, it doesn't mean that it's going to be pointing at the North Pole. It's actually pointing, if you remember from the video, I'll zoom out here and just kind of give you guys an idea of where it's pointing. So as you can see here, we've got the United States. It's actually pointing to an area kind of in this region, instead of, directly above us. And so these lines of variation that run through the map basically tell us the correction, the angle of correction that we need to calculate for, so that we can read the right, course on our compass. So basically, east is least. That's the way we would remember it. Let me write this down.
West.
West is best. So what it means is if we have an eastern line of variation, we need to subtract that from our magnetic heading, right? So say I'm trying to fly a heading of 191 that you see right here. I'd need to subtract 13 from that to get the magnetic heading for that course. Is everybody following along?
Yeah.
I'm trying.
To Tell me to slow down if I need to.
Oh no. I'm just trying to make everything stick. It's just
Oh, and
It all makes sense, but it's just if I had to stop and just do it on my own right now, I couldn't.
yeah,
I mean,
that's
it makes
exactly
sense what
it.
you're saying, but I'm gonna have to take some time and sit down and review this and see exactly what you're talking about to lock.
yeah. So we're just covering right now. We're doing like a high level overview. Okay, we don't expect you guys to know all of this right off the bat. We're going to go through this fast, and like I've said before, this is like drinking from a fire hose. We're just piling information on you as fast as you know we can. Then when you're going to really get a grasp for it and understand it is when we start actually applying it.
Okay.
We're gonna, as we're flight planning and stuff like that, we're gonna go through this again in probably a little more depth and how it actually applies to our flight plans. But what we want to do right here is just give you a crash course on what we're looking at and some of these factors that we need to take into account.
Okay.
So don't feel like you have to have it all memorized, because that's the last thing that needs to happen right now. We're just kind of showing you, introducing it to you, and then as we get, we're just kind of layering it on, right? Each principle gets added to one that we just learned. So we've talked this week. We've talked about VORs, ground-based navigation, right? We also talked about airspaces. Now we're talking about the charts that you're going to see them on, and we're just going to keep layering that until we get to flight planning, and then we're going to take all those things that we learned and we're going to apply them and show you how to apply them and why it's important. So
Okay. That makes me feel better.
Yeah, don't feel like you have to have all this done, and don't think that I'm going to expect you guys to whip out a flight plan as soon as we get done talking about it. So,
Garrett, what would be helpful is that as you navigate around on the map to enlarge your mouse so my eye scan can follow where you're looking.
let me see if I can just make it gigantic. Here, I'm going to stop showing my screen for a second while I go into preferences here.
Your mouse blends in perfectly with legend and everywhere else.
Sorry about that. Let's see. See if there's a way to. I know how to do it on a PC, but this is the first Mac I've ever owned, so I'm still learning how to do all this fun stuff. Why don't we take a break? I'll try to get this figured out during the break. Why don't we take like a... Sorry about that. I had my mic unmuted there for a second, and so I don't know if anybody was around. But yeah.
When do we find out about the scores?
Yeah, I was gonna run over those tonight or tomorrow after work as quickly as I could, but you should have them no later than tomorrow. We're going through some pretty difficult. We're going over some pretty difficult stuff and at work, and so I had to devote a little bit of time to studying last night. Hopefully tonight I'll have a little more time to be able to get to them and get them graded. So, anyways, okay.
Sorry, can you send it to me? I didn't get it.
The test?
Yeah, the quiz.
Okay.
Thank you.
Yeah, I'll send it to you. Let me take care of that really quick so I don't forget.
Okay. Thank you.
Yeah. So I figured out how to get my mouse gigantic too, so that should help. With you guys being able to see what I'm pointing at. Marisa, is it MARIESAY OSHIDA@gmail?
Yes, that's correct.
Okay. Okay, I'll send you the quiz. Just just stick with us in class.
Yeah, I will. I won't do it till after class.
Okay.
Garrett, because you used a different email on mine, I did find it in my junk mail.
Man.
I don't know. I mean, I obviously I got it and took it, but my email didn't recognize your different email. So.
Oh, okay.
Hopefully that's not happening.
Yeah. Let me know if you don't get this. All right. So that's on its way, Marisa.
Okay, thank you.
Yep. All right. So let's get back at it. So, do you guys have any questions on the sectional chart? Do you guys feel like we've covered it pretty well, or?
Yeah, I understand it pretty easily.
All right. And kind of like what we went over before, I'll zoom in just a little bit here. Just remember that we can go to this charts button right here in this top left corner, and then click on the sector that we want to look at, and then it'll also give you that legend on the far left side of the chart. Does everybody see that? So if you're looking at these charts, and I recommend that you guys just kind of open them up and look at them as part of your studying and just get familiar with them. Like I said before, we don't expect you guys to know every little symbol, and you're not going to get tested on the charts so much, but we're really going to learn them and apply them and get familiar with them when we start our flight planning and how they relate to us and what we need to be looking at. So just kind of a crash course right now. Oh, and then also you need to if you want to go back, I highly recommend that you guys go back onto the Google Drive, and in each day there's lesson plans, and it's all the material that we're going over. And then also on our YouTube channel, you can go back and review what we talked about in class. So just keep going back and looking at this information, because it'll really help you in the long run. So with sectional charts being pretty well covered, we're going to start talking about these IFR low en route charts. Once again, I'm just pulling this from the Google Drive in our lesson plan for today. So start with this video. We're going to watch that video, and then I'll also, after you get everybody clicks into this video, I'll paste the next video I want you guys to watch. and then we will come back on and talk about it.
Okay, do you want us to take notes on this video?
Yeah, just kind of take notes on what you're seeing.
Okay.
Like I said, we're going to go kind of in depth again, just like we did with the sectional chart, with this chart, and kind of dissect it. So,
Okay.
all right. So everybody mute your mics and jump into that link, and we'll see you guys back on. We're going to watch both videos back to back. So just look for the link to the second link to drop into the GoToMeeting here in just a minute here.
Like low flying aircrafts and one for high, like commercial aviation aircraft, or is that wrong?
So kind of. So low en route charts refers to low VORs, right? So we're going to be low en route. What is the surface volume? What is the service volume of a low VOR? You guys remember that from yesterday?
Can't remember. Oh, you know what? This is the one we took notes on.
So many acronyms.
Yeah, aviation is great at shorthand, if nothing else. So low VOR, we have three different types of VORs, right? We've got low VOR, high VOR, and terminal VORs. The high VOR has a service volume of 130 nautical miles. Low VORs have a service volume of 40 nautical miles, and terminal VORs have a service volume of 25 nautical miles, right?
Yeah.
Will you say that one more time just to make sure I got it right?
So high VORs have a service volume of 130 nautical miles. Low VORs have a service volume of 40 nautical miles. And terminal VORs have a service volume of 25 nautical miles.
Sweet, thank you.
Okay. So that is required to be memorized. So make sure you guys remember that. So what we're doing is we're, now that we've found out what a low VOR and a high VOR are doing, this is kind of separating the two, right? We've got low charts, low altitude charts, so shorter range, right? And then we have high VORs or high charts as well that are for that larger service volume, and they have different routes on them. So if we put all of the routes on one map, it would be so full of information, it would be almost impossible to read. Because this is a low VOR chart. Look at just what a mess Florida is with this information. Now look when we add high VOR. So this would be the high VOR chart. And if you had both of those together, you just wouldn't be able to read the information that you need off of the chart. So that's why we separate them into two different charts. So let's go over some of these different things on this chart. And you're going to see a lot of similarities between this chart and the high chart. So what are these routes called again? These black lines.
Victor?
Yeah, Victor routes. Okay. So these Victor routes, give us what kind of navigation?
Oh, what does Victor Routes give us?
So it's a point-to-point ground-based navigation system.
Oh yeah, okay.
So we're
so
going to be navigating from one VOR to another VOR. Okay. So we're using these ground-based stations, these VORs, on this map. We're going to be navigating from one of the VORs to another VOR, and that's how we're going to get point to point, right? So
yeah, so the so I put for the numbers that don't have a box around, it's the distance from the VOR to the intersection, right?
So we'll
Like do
just
you know what I
one
mean?
second. I don't know what's going on with my computer here. Just one second. Let me try reloading this map. Oh man, somehow we're out in the middle of nowhere here. Somehow we ended up clearing out Antarctica. Okay, so are you talking about these numbers here, or?
Can't see it because it's all the way zoomed out. Okay, there we go. Yeah, so right next to Victor, yeah, that
Outside the
157 and yeah, so on the right where it says 72. Yeah, right there. So that I put as that's the distance from the VOR to the VOR if it has a number in a box.
Perfect. So, did everybody get that?
Can you say that again? Sorry.
Okay, so this, I don't know if you guys can see that number now that I'm zoomed out a little bit, but I wanted to show you. So, here's a VOR here, and here's a VOR here. Does everybody see the two VORs?
Yeah.
So, this number here, that 72 that's in a box here, that tells us the distance. If we fly this Victor route, that is the distance from this VOR to this VOR. So that being said, what would the 3 twos be?
It's just a half signal.
Okay. So the 3-2 would be from the VOR to the to this waypoint right here, the webs.
Well, that's where I'm getting confused. So if that also has a box around it, so
But it's rounded and it has this arrow on the end of it. Do you see that?
yeah, okay. So if it has that and if it doesn't have a box, it means the same thing, kind of.
No, it's from the VOR to webs.
Yeah. So this is, or not the VOR. I'm sorry. From this waypoint to this waypoint. So the 32, right?
Okay. Okay. I just want to make sure I got that clear because yeah, that's what I put down in my notes is that if there's no box around the number, it's from intersection of VOR. So I just don't want to get that wrong.
Yeah. So that would be this 14. This is from this waypoint to this waypoint. Is 14 nautical miles. This one, 18, is from this waypoint to the VOR. Okay. So yeah, this would be actually from the VOR. If we add this 23 and 9, so that would be from the VOR to this intersection, to the webs intersection. Do you see that? That's the 32. That's why it's in the box, is it's including these two waypoints, this 9 and the 23 here, which equals 32. And it's saying, so what that box is saying is from the VOR to this waypoint would be 32 nautical miles.
Okay.
Does that make sense to everybody?
It does now.
Anybody have questions on that? So these are important numbers to know, to be able to see and know. Okay. So this waypoint, do you guys remember what he said about these waypoints or intersections? This would be the Webb's intersection, right? Heiser, Dad's or Daddy's, one of the two. So these are intersections that we're going to look at when we're doing like our instrument approach procedures and during our flight plan. These are intersections that we'll just kind of use as a reference point on our flight plans when we're doing these longer. Like if you look at this, this from this VOR to this VOR. So from the, let's see, looks like the St. Petersburg VOR here up to the Tallahassee or the Seminole VOR. That's a distance of 182 miles. So we use these waypoints and reference points to help us in our navigation to make sure that we're on course. And so these are the waypoints that the pilots will use just to kind of break it up and help them, their reference points, so that the pilots can make sure they're tracking on the right course. So if they get to this point and it doesn't read exactly where they're supposed to be, then they know they need to correct. Let's see. So what was this longer arrow here with half of it shaded? What is that? Does anybody remember? So we call that a localizer. So it's just the approach into this this airport here. These little green dots here on the map with the kind of crosshairs coming off of them. Those are all of our airports, right? What did he say about the green? Does anybody remember what he said about the green airport symbols? He says that they're the airport has a precision or has a an instrument approach procedure. Okay, the ones that are brown don't have an instrument approach procedure for them. So let's see. So when we're looking at these like these VORs here, how do I know what VOR that is? Does anybody remember?
Yeah, so it's the way you can tell what VOR you're at is let's see. You would, well, there's a frequency 127.25. You're in class alpha airspace. You would, oh no, you're class D airspace. Sorry. You are the ORL.
Hold on. Okay, so so this blue area here, you see this blue shaded area here? That is a class Bravo airspace. We can tell that by the size, and then you can also see this 30 nautical mile circle that says Mode C here. You guys see that? This means that it's Class B airspace. The blue shaded area would be Class B airspace. And then this compass rose here. Huh?
Sorry, what did it say? Mode C?
Yeah, it says Mode C right there. So Class B airspace, the way we can tell a Class B airspace just kind of by a quick visual without having to dive too deep into it, this would be your Class C and D airspace, or I think it's Class C airspace. See how much smaller it is in reference to that Class B airspace?
Okay.
So when you're looking at it, just a quick reference, Class C is going to be this littler circle. Class B is going to be this bigger circle. And the way that we can tell that this is a VOR is the compass rose, right? We can see another VOR up here. We can see another VOR up here. We can see another VOR down here, down here, down here. These little light gray compass roses mean that means that there's a ground-based navigational aid there. Okay. And then in the center of that compass rose, you'll see a little symbol there. That symbol will identify what kind of a ground-based station it is. So this would be a TACAN. Or no, I'm sorry, a VORTAC, which means that it's a VOR with distance measuring equipment on it. Okay. You see this little line that connects to the compass rose here and has this information box. This is what identifies what VOR we're looking at. So this is the Orlando.
It's going down off the screen on my computer.
Okay, I'll pull it up
like
here.
Down below, all you can see is Orlando 112, but below that I can't see it.
Can you see it now?
And the other thing you were showing us, yeah, I can see it now. The other thing you were showing us down below where it said something B is, I couldn't see that either.
The mode C transponder. So right here, that 30 nautical mile blue circle. Do you see that on the screen? So it's right in the center of
it down there now.
So that's just identifying where you have to have a mode C transponder, and that's the only time you're going to see this circle is when it's a Class B airspace. This larger shaded part here, lightly blue shaded area, that's Class B airspace. This one would be a Class C airspace. Okay.
And Garrett, will it always be light blue even if you're not using SkyVector?
Yeah, so those areas are always identified on maps regardless. This is the exact map that the paper, I mean, this is identical to the paper map that you guys will see. And once again, like the guy iterated in the video, was we're not so concerned with the airspace, because as the pilots are flying these planned IFR routes, they're already talking with air traffic control, and air traffic control is going to hand them from one controller to the next. They're constantly being monitored with their progress of flight, and so we're not really worried about what airspace it is so much on this map, and that's why you don't see the other airspaces identified on this map. It's just Class B and Class C. It's just kind of like heads up, you know, because these are more of your high traffic areas. But yeah, so what's important to remember is these VORs here. Okay, remember that lightly shaded gray compass rose, and then every VOR is going to have one of these boxes with the dark black line, and then an information box here. Okay, so this one identifies as Orlando. This station would be Orlando. Here's the frequency that we'd tune into with our navigational radio to pick up this VOR. This is the station identifier, is that ORL. Okay, this code here we don't use in civilian, in the civilian world. That's for military use. And then here's the Morse code identifier I was telling you guys. You'll hear over the radio when you tune into this VOR, you'll identify the station by listening to that Morse code. Okay. So these VORs, this is how we're going to navigate, and these are what we're going to use in our flight planning for our airlines. One other thing to kind of point out, but not really something we're going to be using, is we talked about these waypoints here, or the intersections. Well, these blue stars that you see on the map with a 5-letter identifier, these are GPS waypoints. So once again, we're not really going to be using that in our flight planning. We do what's called green needles navigation.
Garrett, let me kind of jump in for a sec. So there's two ways you're flying a Victor Air route to kind of get yourself to an intersection or ensure you are, either the VOR radio or that localizer. I've used VOR, but on the localizer, how do you tune in and verify that you're on the correct localizer?
So you're gonna refer to your IAPs or your instrument approach charts, and that's going to give you all the radio frequencies and necessary information that actually pertains to that chart or to that approach. So this is just identifying that at this waypoint, this is the start to this approach procedure. As you can tell, some of these bigger airports like Orlando don't have any of those notated on here. It's just certain airports will have that notated on there. But yeah, if we had all of the localizers identified on this chart using those areas, it would just clutter the screen. So once we've identified the localizer or the approach into the airport, we're going to go to that approach for that airport if we want to use it. Does that answer your question?
Well, he just mentioned that it's an alternative to help you find that intercept if you have problems with the VOR radio coming in. And I thought, wow, I could have used that back in the day a couple of times. So
yeah. Sometimes on the instrument approach charts, you don't really get a reference as far as how far those distances are, and it's a little hard to identify where they're starting those approaches. So this, like you said in the video, this just kind of helps identify that that part of the approach, right? And last thing that I'm gonna touch here is these little gray ovals. Does anybody know what those are?
he just mentioned that was the racetrack for a hold if there's problems at the landing airport.
Perfect. Yep, that's just signifying that there's a holding pattern there. So, yeah, I mean, you guys understand it or are getting it, at least from the comments that have been made. So,
Garrett, question, obviously a pilot's using those intercepts various ways with the VOR to kind of check themselves, but how, you're kind of alluding to the fact that the dispatcher is going to have some kind of alert and ability to know when they're at those as well, other than just seeing the kind of the picture of the jet move.
yeah.
How do you do that?
So, so dispatchers, as we're monitoring the progress of the flight, so the only time that you're really going to get to these charts and really use these charts once you start working for an airline is say that there's weather, really bad thunderstorms right here, and our flight plan takes us right through the center of those of that weather. Then we're going to kind of want to know how to route around that weather. So that's the only time that we're really going to use this as a dispatcher where we're going to break out the charts and we're going to kind of figure out where we want to go to route around that weather. And even then, we're going to do a real high level route around. There's VORs that we typically use, or navigation routes that we typically use that we can select from to help us route around these the weather. But as we're flight planning and as we're learning in the dispatch training, we're required to do the full flight plan. So what's important to learn about is, like, this is a VOR. This is the identifier, the 3-code identifier, because when we write out our flight plan, the way we're going to write it is we're going to say we're trying to come from Macon down here to the Wiregrass VOR. The way we would notate that in our IFR flight plan would be MCN dot V323, which is the Victor route, right? And then we'd put a period VUF, which is this VOR, and then we'd put a period and V241. So this is the highway, that Victor route that we're using, and then a period RRS, which would be Wiregrass VOR. That's the route of navigation. So that's how it would be wrote out on our IFR flight plan that we file, right? So that's why it's important to know, this is a VOR, this is the 3-letter identifier, this is a Victor airway, this is how we know how far it is. And then we can see these distances on the waypoints. So when we get into flight planning, that's when we're really going to break it down and say, okay, this is what you really, really need to know on these charts. And this is how we write it out when we do our flight plan. So does that help? Or
Yeah, I completely understand. I was just questioning, I think either the video said it or you had mentioned it, when you get to those intersects or midway points, just progress checks.
Mhm.
Obviously, I understand how the pilot finds it, but how do you know if they're on track? Is there any way in your system you're seeing, okay, he just hit that midpoint, or he hit
yeah,
that?
we can actually it's similar to what was that website you had me look up?
It wasn't me, it was somebody else, but that was cool how it showed all the jets, right?
Yeah, I think it was you, Matt. What was that website that showed all the aircraft? Did we lose him?
So will they just be like, our flights will be little dots on our screen and we can kind of see, like, follow them that way?
Yeah, I'll show you what it kind of looks like. Is it FlightAware? No. I'm trying to remember the website that we went to.
That's okay. I didn't want to derail you. I'm just kind of in my mind that as far as the dispatcher situational awareness, kind of as they go. I'm sure you have tools to do it. It's curious.
I kind of want to show you guys. Kind of want to show you guys what it looks like. Flight radar. This looks like it. Oh, okay. So yeah, this is kind of what it looks like. It's a little more detailed than this, but you can see all these little airplanes flying around in the sky, right? So this is live feed from these aircraft. These are actual aircraft currently flying. You can see this is a SkyWest flight, SkyWest 5848, right? This gives us a little bit of information. It's saying that it's St. Louis to San Francisco. Okay. Says this was our scheduled departure. This is our scheduled arrival. We can see that it was delayed, 16 minutes, and we're estimated to be there at 8:34. So when we look at this, you can see his flight path that he's done so far up to here. Do you see that? You see?
So how did you do that? You just put your cursor on it?
Yeah, I just clicked on the actual aircraft. So this is flightradar24.com. So once I clicked on him, it gave me his flight path and all this information right here, okay? You can see his climb out. You can see where he reached his top of climb. You can see what altitude he's been flying, 34,000 feet. You can see his speed. Ground speed is 378 knots. This is really cool, actually. We can see the type of aircraft, which is an Embraer 175. That's SkyWest's newest aircraft in its fleet. So it's probably, I'm guessing it's going to be, well, it's United. So United 5848. Okay. But the only difference between what we see as a dispatcher is we're going to see the actual flight path coming into San Francisco. So we can see what we've already planned. We can see the VORs, and we can see, we also have real-time weather displayed on our map. And so I can watch the progress of my flight, and I can, if I click on my flight like this, it will show me what route we've planned all the way into San Francisco. And if I see weather interfering with that route, I can actually basically, it's almost as simple as just grabbing that route and dragging it down and then notifying the pilot of the changes. I mean, the software really helps us out once you become a dispatcher. But you need to know the basics of it so that when you do get into dispatch school and when you do actually go out on the floor, you can apply those things and understand why you're doing the things that you're doing. Does that make sense?
This brings on a whole new dimension for sitting in an airport waiting for a delay. I'll just pull this bad boy up and get my own update.
Yeah. So I mean, it's really cool when you actually know, what's going on, why certain things happen. I mean, like you said, it brings a whole nother dimension to your flying. But yeah, it's kind of cool. You can come onto this website and just click on these different aircraft and see what's going on. It's kind of fun, kind of cool to see all of this. But yeah, does anybody have any questions or any more questions about this? Or
Thanks for the extra texture to that.
yeah. So that's where it'll be a little bit different. Is we'll be able to drag and drop it, but in school when you're learning these principles, it's a little bit more difficult than that. You gotta, we've got to go. Oh, we've got to reroute around that weather. So this is the route, and this is the actual, IFR flight plan that we need to file. This is how it needs to be written out. and then we'll calculate the fuel burns and what that does to our aircraft when we make those changes. So, so does everybody feel like they've got a basic understanding of these low VFR charts, or I mean low IFR charts?
Yeah.
Okay.
As much as I can at this point in time.
All right. So
It's a great introduction to them.
yeah. So we're gonna take another break here. We'll do about let's do a 10-minute break. Come back on at 8:30.
Sounds good.
Hello?
Is that you, Yvonne?
Yeah, I'm testing my microphone because for whatever reason, it wasn't working, but it looks like it's working now.
Okay, good.
Sorry about that. Thank you.
No, you're fine. I just wanted to make sure.
Yeah.
All right, everybody back? So, how do you guys feel so far? You guys feel like it's a little rough, but you're understanding it?
Yeah.
You're getting the gist of it? Okay. We're going to watch a video now on the height and route charts. Once again, you're not going to notice too big of a difference between the two.
Okay, I'm sorry. I thought my mic was on, but it turns out my volume was way down. So can you just repeat a little bit of what you said?
Oh, okay. So we're going to watch a video now on the high and route charts. Okay. Once again, not too much changes, but there are changes that you guys are going to need to look out for. So just watch this video. It will probably also help with what we just talked about with the low chart, what we discussed on that, and what we've kind of reviewed. So watch this video, and then we'll get back on and kind of dissect it once again, and then we'll go from there. It's about 33 minutes long. So about 9:05, we'll be jumping back on. All right, see you then. All right. So we're going to jump back into SkyVector here. All right, so once again, not too much different between the high and the low in route chart, right? I mean, a lot of it is basically the same. It gives you a lot of the same information. It just gives you that high service volume. I mean, the VORs look the same. Your numbering system is the same, right? And the only major difference that we see, that's weird, it did it again. Sent me to Alaska this time. The only difference is the types of routes that it shows on the chart, right? So when we're looking at these charts, we're looking at navigation routes called jet routes, right? So these jet routes are kind of like the Victor routes. It's just a higher altitude, right? And usually you're going to be longer distances between your VORs. Like you can see here, 262 nautical miles from Mina VOR to Delta VOR. But other than that, oh, and then we have the Q route. So what's the difference between a jet route and a Q route?
I'll have to get notes from a Q route because all I heard about in the video was some Victor and Juliet routes. I must have not heard anything about Juliet routes.
That's fine. So when we talk about Q routes. And then on our low VOR charts, we have what's called T routes. Okay, let's see. See if we can pull up a T route. Okay, so yeah. So here you have a Victor route. Everybody see the Victor routes? Then you see this T route here. So a T route is a low altitude GPS route. We can see these. Remember how I was saying these blue star symbols are GPS waypoints. So our T routes use those GPS waypoints to navigate rather than VORs. They'll kind of use a VOR and a GPS signal. It combines the two, but the route itself is considered a GPS route. Your Victor routes and then your jet routes are strictly ground-based navigation. But your Q routes are the high-altitude GPS routes. We aren't going to use Q routes or T routes in this class, even though they're oftentimes the quicker point-to-point navigation, usually less mileage and require less of a fuel burn. We're not going to use those in this class. So, but the J routes or jet routes is what we will be primarily using. It gives us those longer distances. Airlines, we typically are flying pretty long distances, right? We're not going from Salt Lake to Ogden or Salt Lake to even Bear Lake, you know. Typically, we're going pretty substantial distances, more like Salt Lake to San Francisco. So it's nicer to have those longer distances between points. It helps us, it kind of simplifies our flight plan a little bit, right? And then the other reason, like I stated last time, pilots that are flying, these faster airliners and jets, how easy, looking at this this high altitude chart, looking at these distances and the waypoints or intersections, and then going to this low chart, how easy would it be for a pilot that's traveling at about 450 knots? How easy would it be, 400 to 450 knots, how easy would it be to be changing over also not only your navigational radios, but also your radio radios, talking with air traffic control? How easy would it be to do that? It probably wouldn't be very easy. That's a lot of stuff going on inside the cockpit, and we don't really want the pilots super overloaded with work, because then they start making mistakes, right? So we simplify it a little bit, give them a little bit longer point-to-point navigation. So that's the real important thing to take away from these high altitude charts. This is the chart, once again, this is a chart that we're going to be primarily using when we start doing our flight planning. Now, if we're flying into a smaller airport, like let's go up here to Kalispell, Montana. Let's see if I can find it here. Let's see, Bowman Regional. Here, we'll just do this. This makes it easy. Man. Glacier Park. Okay, so Kalispell. Let's see right here. So FCA. Sorry, we're going over airport codes at work too. So I'm still trying to get all my airport codes. There's 233 airports that SkyWest flies to, and I have to have them all memorized. So I'm still trying to get used to it all. But if you look at this high altitude chart, you can see that there's not a high altitude route going into Kalispell, right? Kind of the closest VOR that we have, other than the Kalispell VOR, kind of the highest or closest high high altitude VOR that we have is this MLP, Mulin Pass, right? But if we switch to the low chart, we can see that there's a Victor route that goes directly to this low altitude VOR of Kalispell City, and that will start our approach into Kalispell Airport, right? So sometimes when we're navigating, we'll go from, say we're going from, let's do this. We'll go from Seattle to Kalispell. Okay. And let's say that we're flying these jet routes. Oops, here. We're gonna get into how to use this program. I obviously need a refresher on it, but we'll get into it. Let me clear this really quick. It's been a while since I've used this program. So let's see. I'll go Seattle to KGPI. Okay. Then we're going to go Seattle, J12 to EPH, then J70 to MLP, then we'll switch to the low en route chart, and we'll go V536 to FCA. Okay, so that's kind of what our flight plan will look like. And as you can see on this high altitude chart, it kind of takes us off, but we're still on a low altitude route, right? This is kind of what it would look like going into Kalispell, Montana. So sometimes, just depending on where we're trying to get, we're going to switch between the low en route chart and the high en route chart. that way we can navigate from airport to airport. So, so once again, this is going to be the program that we're using. So bookmark this on your internet, and I want you guys to come in and just kind of play around with it. You can see kind of what I did to create this little route here, right? You put in a departure airport and then a destination airport. And you can even like click on the little green dots, all these green dots that you see on the screen. We'll zoom in a little bit. But all of these green dots are going to be airports. So if you click on the green dot and then you click on the airport, this Deer Park, it'll pull up information on that airport. But just kind of go through, play with it. It's
what website is it?
It's SkyVector.com. So yeah, just kind of play around in here. Click on these green dots. You can pull up information about the airport. This will give you all the information about the airport. This is what we'd see in the AFD. This is part of the AFD. This gives us information about the airport, kind of an overview of what we would see at this airport. This is the layout. It tells you the runway numbers, tells you the length and width of the runway, tells you what, kind of threshold or parking or lighting system, kind of gives you a layout of where the buildings are. It tells you, information. It'll give you information about the different runways here. Give you important phone numbers. So, and we'll go into those charts or into those AFDs a little more as well. But then for like your bigger airports, let's go into Seattle. Okay. So we can click on Seattle and we can click on this airport, the little purple line that says Seattle Tacoma Airport. If we come down here, we can see, do you guys remember what we called the arrivals and departures, SIDS and stars? Okay, so STAR stands for Standard Terminal Arrival Charts. And SID stands for, SID stands for, let me see if I can zoom in a little bit. Yep, so here's our STAR chart, Standard Terminal Arrival. And here's our departure procedures, or SIDS, Standard Departure Instrument Departure Procedure, okay? So when we're planning these flights, we'd go into these charts. And RNAV, once again, is GPS, a GPS approach or GPS departure. And we aren't going to be using RNAV in this class, so we'll just use these standard charts. But we can click on this instrument departure and zoom in on it. This is going to give us information about departing the airport, the fixes that they want us to fly to, our exit points. It's going to tell us the departure sequence. So if you're taking off from runway 16 left, we'd climb to a heading of 165, or climb and start heading 165, so 165 degrees. And then Seattle, route 161, right? So then you got takeoff runway 16 center and 16 right. You climb to a heading, and then basically it's giving the pilots this information on how they're supposed to leave the airport. Okay. This gives you the transition information, telling you the waypoints and the routes. But this is what, on an IFR flight plan, this is what we're going to use to notate what departure we're using. Okay. But yeah, so we'll dive into what these SIDS and stars go over. These instrument approach procedures, IAP charts, these are the approach plates that I've been talking about. So if we're doing an approach into runway 16 right, we'd pull up this chart. This is the standard ILS approach procedure. This gives us the navigational frequency that we need to tune into our nav radios. This is giving us our runway landing distances. Okay, so these are the runway distances. This is how long the touchdown zone is. This is the elevation of the airport of each one of these runways. This gives us the true course. So it's 16 left. This 16 is the general heading. So 164, this approach course. This is your true direction that you'd actually be flying, is 164 degrees. Okay, this gives us some information. If we're coming in for a landing and we have to abort our landing, this is the procedure that the pilot follows. So if he's not going to touch down on the runway after he's on that final approach and he goes missed, this is the procedure he'd follow to get out of the way, basically. This gives us some of our holding patterns for our missed approach, right? This is that localizer. Do you guys remember that symbol on the map? That arrow with the shaded half? That's our localizer. This gives us the frequency of that localizer. This gives us the frequency of the Seattle VOR. And we're going to go over this in depth a little bit more. Adam will go over this. But yeah, so I mean, this is all of our minimums if we're, depending on what type of landing we're doing. The standard localizer approach, these would be our minimums. But anyways, yeah, so get into SkyVector, play around, get familiar with the information that you're looking at. Just kind of, you don't have to do it. You're not going to mess anything up, If you get in here and it just starts looking like a mess, you can click this white piece of paper here. Does everybody see that? With the little dog ear on the top right corner. If you click that, It erases everything that you've done and you can start fresh. But come in here and just kind of play around with it, get familiar with it, see if you can build a route,
Garrett, where did you go to get the SID star and IAP charts?
So if you zoom in, go to an airport. You got to go to an airport that has those SIDs and stars. So I would go to like a bigger airport. But if you go to like Seattle, where did Seattle go? It's right here. Whidbey Island, there's Seattle. So if we go into Seattle and click on that little airport information and then scroll down, you can see these standard terminal arrivals and standard instrument departure charts. And then here are your approach plates.
Perfect, thank you.
Yep.
I love that. I love that drag and drop for course change. That's awesome.
Yeah, it's this program is amazing. It makes flight planning a lot easier. And if you actually pay for the software, you can actually file flight plans, IFR flight plans from this software. So it's pretty amazing software. But yeah, play around with that. If you guys have any questions, let me know. You guys have any questions about anything we've covered today?
No.
Just one thing, I'm starting to delineate the difference between the jet and the Q route, and I'm not sure I wrote down what that difference was.
So
the main difference.
yeah, so looking at the map, your high altitude, high en route chart, you'll see the Qs are blue and the Js are black. The difference between the two routes are Q routes use GPS, a combination of GPS and ground-based navigation to make the route. So you'll navigate between VORs, but you'll also use GPS waypoints in those routes. So
then jet is just ground.
Yep, jet uses only ground-based navigation. So so Q routes are going to be a lot more efficient of a route typically. But like I said before, we're not going to use GPS in this course. So.
And the Victor routes are also ground-based only, right?
Yeah. So going to the world low charts, you'll see the Victor routes are ground-based only, similar to a jet route, but for low altitude VORs, right? So those 40 mile service volumes. So you're using those low VORs to navigate point to point. Use it for the Victor routes, but you'll also see the blue T routes, and those are GPS. Those use GPS and ground-based navigation as well. So you can see this T route goes straight through CVO and actually follows this Victor route, but at this waypoint, it switches over to GPS waypoints. So.
Thank you. Very informative tonight. Thank you.
Yeah. Does anybody else have any questions or? All right. Once again, thanks for jumping on tonight. I'll get this video posted to YouTube, and you guys can review it. I highly recommend that you guys go back through and watch those videos as much as you need to. Get on SkyVector and play with it. Look at those legends like we talked about earlier. You can also Google search if you are struggling finding the legends or keys on SkyVector. Just do a Google search for like a high altitude IFR charts or low altitude IFR charts, legends, and it'll pull up, a picture of what each of these mean if you want to get, really dissect and learn what's going on these maps. So if there's no more questions, I guess I'll let you guys go for the night.
Thank you. And I'll send my quiz over this evening, Garrett.
Okay, perfect.
Thank you.
Yeah, thank you.
Thanks, Garrett.
Thank you.
Yep.